And you had to find the third angle, which we could just subtract from 180, and the missing sides, which we set up our law sides. Today, I'm going to switch it up. I'm going to give you 2 sides and only 1 angle. When we do this, we get what is sometimes called the ambiguous case, because there are sometimes multiple triangles that can be formed in this. It might be the case that there is no triangle at all that exists with the information I've given you. It might be the case that there's only 1 triangle, or we might get 2 triangles. So we are going to have to take this problem by problem and see, first of all, if we can get a solution, and then if we get 1 or more than 1. So your answer kind of breaks it down, and it tells you all these different rules. If this and this happens, you're not going to get an answer, and if this and this happens, you're going to get 1 answer. And I think that's just a lot of stuff to remember when we don't really need to. I think the best way to figure this out is just to start solving these and pay attention to our answers. So that's what I'm going to do. So here is our first problem. I want to solve triangle ABC. So you are certainly welcome to draw a triangle if it helps you. I do not care if it is at all accurate, in terms of size of the angles, just place things accordingly. Side A is 17.9. Side C is 13.2. And angle C is 75 degrees, 30 minutes. So when I say to solve everything, we need all the missing angles and sides. When we start, we can't just do Pythagorean theorem and get the third side because it's not a right triangle. We can't just subtract from 180 and get the missing angles because I only have 1 of them. So we are going to have to start with the law sides. The only combo I have everything for is C. So we'll definitely have to use the C over sine C. I also have information about side A, so I'm going to start with those 2 pieces. So side C was 13.2 divided by the sine of angle C, 75 degrees, 30 minutes, equals side A, which was 17.9, over the sine of A, which I do not know. If I cross multiply, then to get my sine A by itself, I will divide by 13.2, and that's what I'm going to plug in my calculator. Make sure you are in degree mode. Remember to type in the 75 degrees, 30 minutes. You do 75 plus 30 over 60 in your calculator. And I get sine A equals 1.3129. Do you see an issue with that? Okay. But this is the value of sine. Yeah, sine can only be between -1 and +1, can't it? Is this even possible? No. If you wanted to find your angle on your calculator, just like in the last chapter, you would type it in as sine inverse of the 1.3129. And if you do that, it tells you error. It's not possible. So this one is no solution. So there is no triangle where this step would be possible. So that is a case where you get no possible triangle. You try to solve it, and you get sine to be something bigger than 1, so it won't work. that one okay? Let's look at this example. Alright, so if I start drawing a picture, if it helps, you don't have to have a picture, it's completely up to you. So angle A is 61.4 degrees, side A is 35.5 centimeters, side B is 39.2 centimeters. So we can't do it like yesterday because I can't find my missing angle, so we have to start with the law of sine. We definitely want to use the A, so we'll need the A over sine A equals, the other side I have information about is the B. And if you prefer, guys, it's completely up to you. In that law of sines, I told you it works if you flip both fractions. So you are welcome to set it up like sine A divided by side of A, and sine of angle B divided by side B, whichever you prefer. It really is going to make no difference. If I plug it into this one, so I have the sine of A, which is 61.4 degrees, over side A, 35.5, equals the sine of B divided by side B is 39.2. This is going to save me one step because I don't have to cross multiply and then divide. So essentially, if you pick the equation that would have your variable on top, it'll be a little bit faster to solve, but it's not a big deal either way. So now all we have to do is multiply over the 39.2 and put that in our calculator. So we get the sine of B equals 0.96949. First of all, is that possible? Can sine equal 0.9?
Yes.
Yes, sine can be anything between positive 1 and negative 1. Okay, here's why we might get multiple answers. Sine is positive in quadrants 1 and 2. So this is like a question I would have put on your last test. So we could be in quadrants 1 or 2. Reference angle, we have to do sine inverse 0.96949. And let's just go to 3 significant digits, that's all we had in the problem. So 75.8 degrees. So here's what can happen. B could be in quadrant 1, your reference angle is your angle. In quadrant 2, what do you do? How do you find your angle in quadrant 2, guys? Just like on the last test. 180 minus that, and so we get 104.2 degrees. In quadrant 1, your reference angle is your angle. So right now, we have an answer, and it looks like we have 2 separate possible triangles. Alright, if we start finding the rest of the stuff then. So I have angles A and B, so to get angle C now, you should just be able to do 180 minus each of these. get 42.8 degrees. So I have B and C. I have side A and side B already, so we need to find side C. We did that yesterday. How am I going to find my third side? Go all sides. Okay, we can use any of these, so let's say I want to find the side, so I'm going to put the side on top. So I'll do A over sine of A equals, we need side C, so we'll have to do C over sine C. So side A was 35.5 divided by the sine, angle A was 61.4 degrees, equals, we don't know side C, over the sine of C, which we got 42.8 degrees for that side. So multiply that over. And I get side C to be 27.5 centimeters. And that was the last thing I had to find. Do a quick check. We've said that the biggest angle will be across from the biggest side, smallest angle across from the smallest side. So in this, B was my biggest angle. Side B was 39.2. Was that my biggest side? My other sides are 27.5 and 35.5, so that is the biggest. Smallest angle was C, and that did turn out to be my smallest side. So that is a good way to kind of double check yourself. Unfortunately, we're not done. This is triangle 1. But we also got that there could be a second triangle in this one. So now we need to solve for the second possible triangle. We have B. To get C, you have to do 180 minus the angles that we have. So that was the 61.4 and the 104.2. So that gives me angle C to be 14.4 degrees. Got B and C. Now we need to find side C, so we're going to do the exact same thing we did over here. So side A was 35.5 over the sine of A, 61.4 degrees, equals side C, we don't know, divided by the sine of C, so sine of 14.4 degrees. So multiply over your sine. Get 10.1 for that side. It's still, B was still the smallest angle on small side, B was still the biggest angle on biggest side, so it all worked out. So that is an example of when you get two triangles. So basically your sine equaled a positive number, and we know sine can be positive in 1 or 2, so we had to look at both. Questions there? Let's do, I'm jumping around a little bit in my examples, but I'm going to come back and hit some more in a minute. Let's do this example next. is 68.7 degrees, side B is 25.4, side A is 19.6. So when I give you two angles to start with, that's like yesterday. We just have to jump right in and start finding our third angle. But if I only give you one angle, we have to do the law of sines multiple times. Since I'm going to find an angle first, I'll put my angles on top. We have to use B because that's the only one we have the information for. I also have the side for A. So I'm going to do sine of A over A equals sine of B over B. Everybody with me? So if we start plugging in, I don't know angle A. Side A is 19.6, angle B 68.7 over the 25.4. So multiply over the 19.6. And everybody should be doing this, not just me. Okay, so we're going to get an answer. Alright?
I got like barely off, like you got 7.18 and I got 7.16.
One of us mistyped. You did 25.5 instead of 25.4.
That's pretty small.
Okay, when is sign positive? How do we get the reference angle? We did it on the last test. What do we do? We did it on the last example even. Yeah, use your calculator. Use the inverse. If you want to move the sign to the other side, you do the inverse, just like I have written up on the board from a previous example. So A equals the sine inverse. So you hit second sine, 0.71894. And we get, let's see, all these are rounded to the nearest tenth. So that would give us a 46.0 degrees, so just 46 degrees. Okay, so my two triangles, triangle 1 and triangle 2. In quadrant 1, your reference angle is your angle. In triangle 2, you have to do 180 minus that. So 180 minus 46, 134 degrees. Okay. So far, so good? So let's solve triangle 1. I have now angles A and B, so angle C should be easy. You just do 180 minus both of those, so 180 minus 46 minus 68.7, and we get 65.3 degrees. We have sides B and A, so to get C, we're just going to use law of sine, so we could do like A over sine A equals C over sine C. So side A was 19.6 divided by the sine of 46 equals C, we don't know, over the sine of 65.3. So you have to multiply over the sine of 65.3. C turns out to be 24.8 inches. So that was the rest of the information we needed from the triangle.
Did you find the quadrant for 2?
We have not. We have angle A in quadrant 2, but I haven't found anything else yet, so we're getting ready to. So for quadrant 2, if I were to find my C, you have to do 180 minus the angles we have, which is the 134 and the 68.7. When you do that, you get C to be a negative 22.7 degrees. Is that possible? If I have a triangle, can you have a negative angle in a triangle itself? No. So in this problem, triangle 2 does not exist, and there's only one triangle. So those are the 3 scenarios. We've seen a case where we have no triangles. Come in. Because when we set it up, we get sine to equal a value that is not possible. You're welcome. Got it? Yeah. We've seen a case where we have the 2 triangles because we do the quadrants 1 and 2, and we're able to find all 3 angles. And we have a case where there's only 1 triangle because the quadrant 2 triangle gives you a negative for one of your remaining angles. So those are the 3 possible scenarios. To me, it is a lot easier than trying to follow the rules in the books about when things are going to happen, because it's pretty obvious when we're solving it if it's going to work or not. You know, if you get a negative angle, that's not possible. If you get sine to be something bigger than 1, it's not possible.
So every time we are thinking that it's 2 triangles?
Yeah, basically start out with that assumption until you're proven otherwise. Trying to decide what I want to do. Let's do maybe one more problem. So I'm not going to tell you which of the 3 cases it is. I'm just going to put a problem up here and we'll see which one it turns out to be. Okay, so let's say A is 55.3 degrees, side A is 22.8 feet, and side B is 24.9 feet. I'm going to give you a minute to set up as much as you can, and then I'm going to start setting mine up here. You can keep working if you want, or check yourself. So you started with your law of sines using A's and B's. And you get sine of B to equal 0.897868. You want to keep a few decimal places here, because we're not to our final answer yet. So first of all, will this triangle exist? Yes. So we know sine can be positive in 1 or 2. Reference angle, so you do sine inverse of that, And this is where you can just round to the same significant digits as the problem, so we get sine, or theta to be 63.9 degrees. So in triangle 1, my angle B, in quadrant 1, your reference angle is equal to your angle, so that's 63.9. In quadrant 2, you have to do what? 180 minus that, and you get 116.1 degrees. So we are working under the assumption right now that there are two triangles. To find C, you do 180 minus those. So minus the 63.9 and the 55.3 from the problem. And that's 60.8, so we do have this triangle. If I went ahead and found C over here, if you did 180 minus the 116.1 and minus 55.3, we get 8.6 degrees. So do we have two triangles? Yes, as long as those are both positive, we've got two.
For those, the 63.9 and
Mhm.
the 116.1, you did 180 minus.
The reference angles.
Okay.
So this one.
And then that would be for quadrant 1.
That's for the quadrant 2. In quadrant 1, your angle is just equal to the reference angle.
Okay.
Alright, so we had sides A and B to begin with, so we need C. So I'll do A over sine A equals C over sine of C. So that's 22.8 over the sine 55.3 equals C over the sine of 60.8. So we can multiply that over. And our side is 24.2 feet. To find your side in the other triangle, it's going to be set up the same way. The only change is the angle C is an 8.6 this time. In this case, you get 4.15 feet. Any questions? So I am stopping here. So this is the assignment. Again, odds, but you have to have work to support your answers. Don't just write down the final answer. Tomorrow, I am going to give you class time to work. It's not that, there's not that many problems, but I know, especially when it turns out to two triangles, they do take a little bit, so I will give you class time tomorrow to work on this. You've got about 10 minutes or so right now.